And now, it's my pleasure to introduce our keynote speaker. Candace Thille is the director of the Open Learning Initiative at Carnegie Mellon University, a position she has held since the program's inception in 2002. Candace's focus of research and development is in applying results from the learning sciences to the design, implementation, and evaluation of open web-based learning environments. Candace serves as a redesign scholar for the National Center for Academic Transformation, as a fellow of International Society for Design and Development in Education, on the Assessment 2020 Task Force at American Board of Internal Medicine, on the Technical Advisory Committee for the AAU STEM initiative, and on the Global Executive Advisory Board for Hewlett Packard's Catalyst initiative. She has served on the working group at the U.S. Department of Education to co-author the National Education Technology Plan. Many of us here are familiar with that. And on the working group of the President's Council of Advisors in Science and Technology, PCAST, to write the Engage to Excel report on improving STEM higher education for the Obama administration. And on a personal note, I know that Candace shares in many of the same values and the same aspirations that we do for improving teaching and learning across the country, and especially in higher education. She is a delight and creative, thinking out of the box, but at the same time has her feet on the ground. And so I welcome Dr. Thille. Welcome to Towson University.
Put my eyes on. So what I'm going to talk about today is the project that I run at Carnegie Mellon called the Open Learning Initiative. And when we were listening to Jane, it reminded me a little bit about our beginning, which was back in 2002. So before I start telling you about the project, I will say that when we started, it started as an open educational resources project. Funded by the William and Flora Hewlett Foundation. And right about that time, they funded another big open educational resources project, which I think took most of the media attention. How many of you have heard of MIT's OpenCourseWare? Just show of hands. Okay, so we started like a year later. And in fact, the Hewlett Foundation came to us and said, will you do an OpenCourseWare? And we said, well, actually, we don't want to do an OpenCourseWare. We want to do this different thing. We want to bring together teams of domain experts, learning science researchers, software engineers, and see, can we create learning environments that would support independent learners, anybody out in the world who didn't have the privilege of attending an institution like Towson, but just, by gum, wanted to learn statistics. Because that's such a natural human drive. I just want to learn statistics. Could we create an environment that would support those learners to do that? And it was out of that idea that we started the Open Learning Initiative. So it's interesting to me to see the direction that MOOCs are going now with it's the same kind of target. And they came up with a very different solution to the kind of challenge that we were trying to address. So I'll speak a little bit, and I am a big fan of interaction, and I know this is kind of a big group, but do not hesitate at any point if you have something you want to say, a question you want to ask, something that you just want to share with the group, to stop me and do that. I'm real flexible. If I only get through 2 slides, that's fine. Yes?
You may want to define what a MOOC is.
Thank you. Okay, a MOOC, it stands for a massively open online course. And MOOCs were actually, that term was actually coined back in 2008 to refer to a course that George Siemens up at Athabasca University was running, where what he was creating a course for his students at Athabasca, but then he opened the online course up to anybody who wanted to enroll. not for credit. And he had about 2,300 students enroll in that first MOOC. It was a different structure in that his idea was that it was a very constructivist approach, where his idea was that the students, along with the experts, co-create the learning experience. So he was using the technology at that time to create a course where the students were also helping sort of say what we should be reading, say what should be working on, really engage in co-creating the course. That term was again used, the second time the term used, which is when it really took off, was when Sebastian Thrun, a faculty member from Stanford, had a course that they opened to the world, also an online course, that 160,000 students registered in. And so he referred to that as a massively open online course. And that's where the media kind of took the term MOOC and ran with it. And since that time, Sebastian has spun out a company from Stanford called Udacity, where he's offering these kinds of massively open online courses, as well as Coursera, which was another company that was spun out of Stanford by two other Stanford faculty, Daphne Kohler and Andrew Ng, and then we have edX, which came out of a collaboration between MIT and Harvard. So that's what MOOCs are. And people always ask me, is OLI a MOOC? And I don't think so, but we'll kind of get clear on that as we move through. So what is the Open Learning Initiative? It's not a MOOC. It's basically, it is a MOOC in the sense that it is massively open online courses, but our environments are not designed to just be the traditional form of instruction made massively open. What we're really looking at is how do we take what we know about human learning, leverage the technology to both make learning widely available, but also to learn more about human learning. And I'll explain a little bit about how that works. One of the things is that all of our courses are designed with our current understanding of how people learn. So we look at the learning research, we say, what do we learn from that, and how does that inform our course design? And so our courses are not recorded lectures. What they are collections of exposition, some exposition, but a lot of interactive activities designed to support the learners to achieve certain learning outcomes. So let me give you an example. I'll give you an example out of our engineering statics course. Do we have engineers in the room? Yay, okay, so Carnegie Mellon has a couple engineers, and computer scientists, and so we got very excited about thinking about how do we teach an introductory sophomore level statics course, and what are the real challenges that students confront when they're trying to make it through the engineering course. And so one of the activities that we designed was this activity, and this is on how to sum essentially concurrent forces. So those of you who aren't engineers, you may have done something like this in some math course that you took a long time ago, or physics course a long time ago. But basically, we give the student 3 vectors, and we ask them a simple question. What's the direction and the magnitude of the sum? So you can go ahead and pull out a piece of paper and do this if you want. Kind of work it out, see how quickly you can get it. But in any case, so we ask the students basically, you know, what's the direction magnitude of them? If the student can't do that, can't get out a piece of paper and just work it out, they can ask for a hint. And you can see that little green button there, and the student asks for a hint, or even if they type in an answer and the system evaluates that as not quite correct, they can ask for a hint. So the hint then walks the student through how we want them to think about solving this problem. So the first thing that the system asks is, do you want some help? You know, if you're not sure how to do this, do you want to remember what the first step is in this procedure? And if the student says yes, then the tutor expands. And it says, remember, the first step is to resolve each of these forces into its components. Can you do that? So the student can try typing in the first force, and again, they'll get immediate feedback. If they're stuck, they can get a hint. And again, the system walks them through how they should be thinking about solving that first sub-step. And then they get to the 3rd level hint, which we call the bottom-out hint, commonly referred to as the answer. And so they can go ahead and type in, 4.79 or whatever it is in this case, and keep moving on. So then they do the next few pieces, and then the system's like, great, You've done that first step. Now can you answer the big question? Well, no, I'm not quite sure yet. So you can ask for more help. And again, the system just keeps expanding to give the student the help as they're asking for it. So I sort of fast forwarded here so you can see that the student has been able to finally answer the question, but that they used a lot of the scaffolding that's been available. So the system then asks the student, great that you were able to do this, but really what we would expect is at this point in your learning for you to be able to do these kind of summing vectors without all this support and feedback. So click here and you can try again. And the system will generate a new activity. All the hints, all the feedback will be conditioned to that new activity. So what we're basically providing to students here is 24/7 support in their problem-solving process. So how many of you have heard about learn by doing? Learn by doing, yes, okay. And people took that learn by doing idea and ran with it, which is great. But really, when you're having students do something, you're asking them to do something because what you're really hoping is it'll support them to think something. You don't want students just to mechanically be moving through procedures without thinking about what is it that I'm really reflecting on and getting from this experience. So the reason we have cognitive scientists working on the project is because as we're designing these experiences, as we're designing the hints and feedback, what we're trying to create actually is cognitive scaffolding. Scaffolding for the student to start thinking the way we want them to think when they're engaged in practice. So all of those hints and feedback that I kind of quickly ran through, those are all, we think through those about what do we want the students to be thinking when they're trying to solve that particular challenge and condition the hints around that. So now a lot of you might be thinking, okay, that's great. I can see how this works really well for things like summing force vectors. For all the engineers in the room, great. But higher education is more than just problem solving, right? Right. So we need students to be able to do more than just, if you give them a problem, solve the problem. So when we're designing, I just showed you a single activity. When we're designing the courses, we're really thinking about what's the big picture? What's the big picture we want the students to get? And how do we want them to make the connections among all these little discrete activities that they're learning and that big picture? So for example, when we designed our, the thing that I just showed you was called a cognitive tutor. And that's based on work that we've been doing at Carnegie Mellon for the past 15 or 20 years. And that's basically just taking a piece of software and asking it to support a student as a good human tutor would. So when the student's moving through a problem, they are getting support and feedback when they need it. They can get hints when they ask for it. And when they're just moving along, the system stays back and watches them and doesn't intervene. But when we did our chemistry course, one of the things we noticed at Carnegie Mellon is the students that were majoring in chemistry at Carnegie Mellon were very good at high school chemistry. That's how they got into Carnegie Mellon. And they had some really good strategies that served them really well in their high school chemistry course. And that is, we'd give them these really complex mathematical chemistry problems. They would take the problem. They would know, okay, this is week 3, so we're in chapter 5 of the textbook. Flip through the textbook, find a problem that looks a lot like the problem on my homework, take the values in the question on my homework, plug it into the process that's outlined in the textbook, solve the math, because I'm really good at math, get the answer, get an A, have no idea what that mathematical thing I just did had any connection to chemistry, or how that chemistry would have any connection to the real world. So we watched them doing that and thought we need to interrupt that, for them, very successful means-ends analysis approach to solving problems. So we changed the tasks we gave them. And we gave them this virtual lab environment in which they had to essentially construct the experiments and really connect the mathematics to the chemistry. Then we situated the chemistry in a real-world problem so they connect that chemistry to the real world. And the problem that we chose was the arsenic contamination of the water supply in Bangladesh, which is a real world problem. And so the first thing they get when they take their stoichiometry unit is they see a little video that explains what the problem is in Bangladesh. And then they get put in the role of chemist. And they're asked with a virtual well water sample out of this well, and they're put in the chemistry lab, and they're asked, is the arsenic level in this well water sample safe to drink? And if you look at what the student sees, you can see there's a solution viewer, and it tells them how much arsenic is in that sample. But are there chemists in the room? No chemists. Okay, yay, chemist. But you can see, I'll talk to you. You can see in that sample, it tells them how many moles of arsenic are in that water. And the World Health Organization tells them how many micrograms per liter of arsenic is safe to drink. So even to solve the very first question, they have to be able to do that conversion. Again, if they can do it, they can just go ahead and do it and move on. If not, the system will give them hints and feedback. If it's really clear that they have no sense of what they're doing, then the system will put them into a just-in-time learning experience, which explains how to do the dimensional analysis, gives them worked examples, gives them tutored problem solving, and so on. Then once they can do that, they get put back into the scenario and learn about a solution that a Bangladeshi chemist came up with, which was using local clays to create filtration systems. But the problem with clay is because it's a natural substance, its absorption capacity is different depending on what clay you use. So then they have to analyze the absorptive capacity of that clay to absorb arsenic. So they can answer a question like, how often would a family of 4 have to change the water filter in order to keep their water safe? So by pulling them through this scenario, they are actually using the tools of stoichiometry, but bringing them to bear on real world problems the way a chemist would. And I always get the question when we anticipate this question. I always get the question from faculty who are in the history and English and literature saying, okay, that's great, but what we want our students to get is so much more than what the chemistry faculty or the engineering faculty want. Yeah? Everyone was thinking that. And so what I love is when I have chemistry and engineering faculty in there, and I can ask them, is that what you want? Is it what you want for your students to be able to just solve these problems? Is that what you're going for? There aren't enough of you in the room for me to get a good conversation like that. So I'll tell you what often they say. I had one, this is my favorite answer. I had a chemistry faculty member, I don't remember who it was, where it was, who said to me, no, Candace, I want the same thing the history faculty want. I want my students, when they're taking a chemistry course, to be, and I love this, you can use this quote, to be able to authentically participate in the discourse of chemistry. Can you believe that? From a chemistry faculty member, isn't that great? And I think that's really part of what we want. We want students to be able to see the world or see what have their perspective be in some ways addressed by the discourse of the domain we're teaching them. So when I'm teaching them history, I want them to start to look at what's going on in the world from a historian's perspective. When I'm teaching literature, I want them to be able to, when they come up against something, to be able to see, oh, that reminds me of what happened in Madame Bovary. Or, so to really have their perspective in some ways enriched by the experience of what they're doing in class. And so you say, how do you do that with a computer? Well, at this point in time, we don't. But what we can do with a computer is take a lot of the stuff that we have students currently do in class and have them learn it effectively outside of class, so that the time we spend with them in class, we can actually spend engaged in those kinds of interactions that really give them the enriched experience we want them to have. But more on that. What you can see happening, and this is part of why we can do this, because what you can see happening in those little examples I gave you is as the student is working through the material, they're getting feedback, context-specific, pretty constant feedback, so they can use that to refine their performance. It makes their out-of-class homework time much more effective. What you're not seeing is the other thing that's happening is as the student is working through those activities, not only are they getting feedback, but we're collecting the interaction level data on what they're doing. And we're using that data to drive feedback loops to another really important actor in this educational system. So we give feedback to the student. The other person we give feedback to is the faculty member. So, and this can change how you can use your class time, as I was describing. So rather than saying to the student, if you say you teach Mondays and Wednesdays at 10 a.m., rather than saying to the student, work through chapter 3 or read these articles before you come to class next, you can say it's Wednesday, say work through module 3 of the OLI course before 10 o'clock Sunday night. And because we're gonna meet on Monday morning at 10. The student's working through the module, they're getting the hints and feedback and support, the system is collecting that data. And then you as the faculty member on Sunday night can look at what we call the instructor learning dashboard. And I'll give you an example out of our statistics course. And this is an actual screenshot of a faculty member's dashboard in a class that's running at another institution, not Carnegie Mellon, not Towson, but another institution. And so this is a screen capture. What this is out of our statistics course. This is the second module in the statistics course where students are learning about distributions of variables. And as you can see, we have the learning outcomes that are articulated for that module. Now I want you to notice that the learning outcomes are all stated in what we think of as student-centered and observable measures. So the faculty member can just quickly look at this dashboard. I've only got 10 minutes. I can quickly look at this dashboard and see on these outcomes, where's my class? So the students that are in each bar represents the current knowledge state of just my class. So the students in the green bar, that percentage of the bar that's green, that tells me if I were to give students a task today, in class today, that assess that particular outcome, the system is predicting that most of the students in my class would just nail it. They do fine. As you go down, you can see a little bit more variability till you get to the one about relating the measures of center and spread to the shape of a distribution. That's got a lot of variability. The students in the green bar, we'd say they are doing fine. The students in the orange bar, we'd say their learning level is moderate. The students in red, we'd say those students are really struggling. They're working, but they're really struggling. Anybody got a guess about what the gray section means? Yeah, the students haven't done enough work in the OLI system for us to make any kind of reliable prediction for you. So the instructor, you can just quickly look at this, decide where am I going to focus my attention, or if you have a little more time, you can drill down and see what's going on. So you could click on the bar, and that will expand your information in a couple ways. One of them is, it'll tell you that each dot in this, there are 40 students in this class, each dot is a student. It also tells you on the other side that that larger outcome has some component skills that are associated with that. So you can see is part of their trouble in being able to look at the shape of a distribution because they can't, say, compute the median. You can also click in further and see for those dots, like I clicked on the orange one, for those dots, who are those students? Now, as I said, this is a real class, so I took the student names off. If you were the faculty member, the student names would be appearing there. And it tells me not only who those students are, but how many activities they've engaged in that pertain to that particular outcome that's driving that prediction. I can also click onto any individual student name and see for that student, how are they progressing against those outcomes. And for the outcome, the one that's orange, I can see which activities have they engaged in and which ones have they not engaged in yet that's driving that prediction. I can also click in and see what's the activity. So for example, when I said one of the challenges was compute the median, this is one of the activities in the course where we're probing whether the students can compute the median. And this is about looking at the readability of pamphlets for cancer patients. Now, one of the things I want to say that you can do with the technology that's kind of cool is that when you're trying to understand, can a student compute the median, what we used to have to do is say, okay, here are 10 problems with arrays of numbers, compute the median. And the student's like, oh, I'm computing the median. And then tried and tried and tried and tried. And you can say, okay, they got 50, they got half of those right, they kind of know it. But but that's not just what we want students to be able to do. We don't want to know, can they just compute the median? We want to know, do they recognize when computing the median is the thing that I need to do to help me make traction on this larger question I'm trying to answer? So can I recognize when to compute the median? Then can I compute the median? Then can I take the answer I got and apply it back to informing the question I was really trying to solve? And so what we can do in the technology is give students big, interesting tasks to do, where a substep of that task is computing the median. So they don't know, oh, what I'm trying to do now is compute the median. I'm trying to solve this bigger, more interesting challenge. But the computer can tell when I get to that sub-step where I'm trying to compute the median, if I ask for a hint or need feedback or get lots of support, then the system can go, oh, you're struggling with computing the median. And in multiple interesting problems that have all different kinds of shapes and sizes, we can probe that single little knowledge component and give you, the faculty member, good information in the context of doing larger tasks where students are struggling. So that's one of the powers of the technology, is being able to do a lot of that analysis to help you target where your students' needs are. So that gets me to, what are the affordances of this technology? So usually when people talk about the power of this technology, they talk about these one of three things. So one of them is the first thing, which is that technology is great at access. That's the great thing about online and MOOCs, is we can create something and hundreds of thousands of students can have access to it. And that's really a good thing. The second thing is these really cool things you can do with the technology. You can do simulations, you can do all kinds of interactivities that allow students to see things at macro scales and micro scales and build bridges, simulated bridges, and collapse them without killing anyone. You can do all kinds of cool things where students can practice and engage in authentic tasks without creating any irreparable harm. And that's really cool. And the third one is what sort of the original MOOCs were trying to do, connectivity. You can use the technology to connect students to each other, to connect students to experts, to connect students to the world. And these three things are real powers of the technology: the access, convenience, simulation, connectivity. But I submit that these aren't the biggest power of this technology. The biggest power of this technology is actually what Google has figured out. It's what Netflix has figured out. It's what Amazon has figured out. The power of this technology is not just pushing stuff out, but just pushing it out far enough that we can have the students interact with it, so we can use this technology as great big data collectors. And that is what I think of as the killer app. That you push it out just far enough and you design it so that the interactions the students are having with it are meaningful, so that we can learn a lot about the students. Now, Amazon, Google, Amazon, Netflix, they're all trying to watch our clickstream to learn a lot about us as consumers. And they do that because they want to personalize the experience to us, and also because they want to learn more about consumers in general. Well, we can use the technology in the same way, but to learn about our students as learners, both so we can possibly personalize their experience, but also so we can learn a lot more than we currently know about human learning. So that the design of the environments, the design of the learning experiences we create are based on something we can really understand about how our students and how people learn. And that is the sister project to my project. My project's the Open Learning Initiative. The sister project to my project at Carnegie Mellon is called the Pittsburgh Science of Learning Center, which is a big NSF funded, well-funded, to the tune of $50 million, well-funded research center that's a collaboration between Carnegie Mellon and the University of Pittsburgh. And the whole purpose of the Pittsburgh Science of Learning is to essentially understand human learning, create and refine theories of human learning. And the Pittsburgh Science of Learning Center uses the OLI environments as a research lab, because we're creating these big open educational resources that then students are using, and they can introduce different experiments into the environment. They can analyze the data and learn a lot about human learning. And then we get the benefit because everything that they're learning about human learning helps inform the design of our environment. So it's a really nice synergistic relationship. And this is, I was talking about the data collection that we do. So some of the data goes, as I said, to the student. Some of the representation of the data, as I showed you, goes to the instructor. Some of the data goes to the Pittsburgh Science of Learning Center so they can understand what's happening with human learning. It also goes to the course design teams. So this is that same data, this is a different representation. So this is what we call a learning curve analysis. Now, when I showed you guys the engineering statics tutor, did it bother anybody that the students could just kind of go, hint, 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 type in the answer? Hint, 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 type in the answer. Did that bother anyone? Because oftentimes, well, my students are just going to go hint, 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 type in the answer. And they can, and they do. But the difference is we know it. So this is one of the places it would show up. This is a learning curve analysis, and the y-axis is what we call the assistance score. That's when a student is working on some subtask, the number of hints or feedback that the student got when they were trying to solve that little sub-step, which could be, that decomposing that one vector for us. It could be computing the median. But when I was saying we can collect the student's interaction across multiple complex tasks, but then isolate the components. So that's what I'm talking about, one of those kind of components. So the y-axis is their assistance score. The x-axis is the number of opportunities they've had to demonstrate that knowledge component. This is the kind of learning curve we like to see. This shows us that learning is happening. Because at the beginning, when the student first, I think this was calculate Avogadro's number, when the student first was given that task, they needed a lot of support and assistance. But over time with practice, each dot is a practice opportunity, they needed less and less support. Till at the end, they need virtually no support. We don't always see these graphs. Sometimes we see them where they start up high like that and they kind of flicker around up there, but they stay high. What would that tell you? Yeah, could be that student's doing that hint, 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 hint thing, yeah. Yeah, it tells us that the student's engaging, but the engagement that they're doing is not helping them learn. Another thing that we sometimes see is it starts down at the bottom and kind of fluctuates along there. What would that tell you? Yeah, we're wasting their time. We're giving them lots of practice on something they actually don't need a lot of practice on. And then sometimes, and I don't expect you guys to get this one, it looks just kind of random, where it's kind of going like this. Anybody got any guesses? Usually that means that we've sort of misspecified the knowledge model, that there's something that we thought was a single knowledge component. Actually, we've introduced a level of complexity that introduced a new knowledge component. And so sometimes you'll see, I might even have a graph, where you get a nice downsloping graph, and then there's a point of inflection where it jumps back up again. And it's like, oh, and then we can drill down and see what's happening at that point and unpack that. So the other group that gets the data is, I mentioned the design team, and this is what our design teams look like. So in our design teams, we have domain experts, the disciplinary faculty, and usually multiple faculty, learning science researchers, software engineers, human-computer interaction experts, instructional design folks, students, We put together these design teams that then, because we think of every environment that we create as basically a hypothesis. Based on what we know about human learning, based on the challenges of the domain, based on what we can do with the technology, we think that this thing that we're creating will support students to get to these outcomes. But we don't know until we actually have real students using them. So then we create our first instance, we put it out there, and we have multiple faculty and students in multiple classrooms using these environments. And then we collect that feedback, and we collect the faculty experience, and use that to inform the next iteration of the course. So we run on a pretty constant research cycle of the learning science informs the first design, then the actual use of the environment informs both the next design and the learning research. So there are multiple ways faculty are involved. They can be involved in the core design team, they can be involved in the review and contribute, or they can be involved in the use and evaluation research. And what we know is that this is a new way of thinking about designing and implementing web-based learning environments. And in the past, when we used to do this, it was extremely labor-intensive. It still is pretty labor, but it was really labor-intensive because in order to do these cognitive task analyses took a lot of time and of both the faculty and the learning researchers to unpack the expertise in order to design these environments. But we did have good effect. We were able to show often 60% or better increase in learning outcomes with these redesigned environments. But the new opportunity now is using these data analysis tools to be able to do that cognitive task analysis in the way that I was describing, where we use the data representations to target where to focus our activity. So that so we're using the technology on both sides to help us also in the design. And we have a bunch of studies that we've done and that others have done showing that students using the OLI environments can learn the material in an accelerated fashion. And in fact, this study was kind of interesting because the first study we did was, because remember the original goal from the Hewlett Foundation was create an environment where students can learn, in this case, statistics as well, just using the online environment as the students sitting in the comparable course at Carnegie Mellon. That was the original design challenge. So the first study we did was addressing that challenge. And now, as you can imagine, I went to my institutional review board and said, I want to do this study. And they're like, are you crazy? Because what I want to do is randomly assign the student, like if you signed up for introductory statistics at Carnegie Mellon, I wanted to randomly assign you to the OLI condition or to the traditional condition. And my IRB said, no, you can't do that, Candace. So we did a modified thing. But the first condition that we did was the students using the OLI course met with a faculty member still, but they met with a faculty member once a week for 15 weeks. And we told the faculty member, you cannot teach during that session because we're really trying to see, will the environment actually teach the students? You can answer questions. And then I had a graduate student in there taking notes. Anytime a student asked a content question and the instructor answered it in a meaningful way so that we could understand what teaching in addition to the OLI course was actually happening. But also, that was good information for me about when the students are asking these questions, that's where they're not getting it. So we can use that to refine the course. So we did that first experiment and got really interesting results. The students in the OLI condition actually did as well or better than the students in the traditional four lecture a week class. So my program officer from Hewlett came. I was all excited to show him. Is Mike Smith, was my program officer at the time. And I showed him, I said, look, we did it. And he went, that's kind of interesting, Candace. But if everything you've told me, that you've been sort of drilling me with this idea of cognitive science and 24/7 support and personalization, why didn't the students in the OLI condition do better than the students sitting in the traditional course? I said, better? You know, let me explain to you, Mike. I mean, those of you who are researchers here, trying to show learning gain, measure it on that size population, you know, that's really, so how do you want me to show you better? He said, how about faster? Show me that students using the OLI course, even with an instructor supporting them, can do the course faster. And so we did these accelerated learning studies. And the accelerated learning studies were, again, my IRB would not let me randomly assign to condition, but what they would let me do is send out an email to all the students that were registered in the intro stat course for the next semester and tell them we were doing this study and ask them if they wanted to participate. And for those that wanted to participate, they filled out a demographic survey, and so that I could, and then from that group, I could randomly assign them to condition. So the two conditions were traditional Carnegie Mellon statistics course, which meets 4 times a week, 3 times in lecture, 1 time in lab, textbook, 3 midterms, a final, 15 weeks. Or accelerated condition, you meet once a week with a faculty member and finish the course in 8 weeks instead of 15 weeks. And instead of a textbook, you use the OLI environment. And the students, so we got the students to volunteer, randomly assigned them to condition. We had 2 controls. We had the control condition of the students who didn't volunteer, that were just taking the traditional course they signed up for. And we had the condition of the students who volunteered and got assigned to the control condition. And then we had the experimental condition. And there was, which was good because we had then 2 controls. And there was actually no difference between the 2 control conditions in any of the measures. And then with the experimental condition, the students finished the course in 8 weeks. And they did on all measures as well or better than the students in the traditional condition. Yeah?
In both cases, they were full-time students?
They were full-time, yes. Yes, in both cases, they were full-time students. They didn't receive any break on their class load on anything else. And in fact, during the semester, we sampled out of each condition to look at how much time were the students spending on statistics. Because the concern was that they would just compress and cram. And the students in the OLI condition were spending no more time on statistics than the students in the traditional condition. We also brought them back to our lab the following, this research happened in the spring semester, and we brought them back in the fall semester to do a retention study. And there was no significant difference in retention between the 2 conditions. So we published this study, and people were like, oh, that's too good to be true. So we replicated it 2 more times with different class sizes and different faculty and got essentially the same result. Now, I don't think that's because the OLI course is better than an instructor. I think it's because what happened was the students came into class basically prepared to engage with the faculty member. And the faculty member then was able to use that class time really demonstrating the way a statistician thinks about and approaches statistics. And in fact, the faculty member who was the guy who ran the first accelerated learning study, he was a real skeptic about this before he did this, because he is one of those faculty members who I'm sure is like a lot of you in this room, who teaches in a high relationship sort of way, that part of how his students learn is in relationship with him. And in fact, there are websites at Carnegie Mellon about this particular faculty member that are just like, that students sort of spontaneously put up as sort of fan sites, because he clearly cares about his students. So he was really worried, if I'm only getting them for half the semester and during that time I don't get them for as much, I'm not going to be able to establish that relationship. But what he said was, after the experiment, that this was actually the best experience he'd had in his 15 years of teaching statistics. And I asked him why. And he said, well, for the first time, students came to class and they knew what they knew and what they didn't know. I knew from looking at the instructor dashboard what they knew and what they didn't know. But probably more importantly, they knew that I knew what they knew and what they didn't know. So we spent that limited time we had together really aligned on moving them from here to there. And so he was like, this, and it's interesting because at Carnegie Mellon, when we started this project, I should mention, we started this project, we did not start it as a creating technology to support instruction at Carnegie Mellon. In fact, every department that I went to and said, oh, I got this cool grant, you want to play? Every department that I went to said the same thing. Yes, Candace, we'll be happy to create these open educational resources, happy to provide this to the world, but let's be clear. These environments we're creating, these are for the world. These will not be used at Carnegie Mellon. Because you remember, this is 2002, when the rap about online courses or online technologies was very much, they're much worse than they take away from the relay, all that kind of stuff. So it's like, fine, that's what we're doing. I'll tell you, every single one of these courses that we developed for this purpose is now being used at Carnegie Mellon. And now I have faculty. I don't have the grant funding to develop at Carnegie Mellon anymore, but I have faculty that are coming from different departments at Carnegie Mellon saying, can I work with you? Can I create an OLI component to my course? Because the faculty are seeing that it's not replacing them. What it's doing is making their students much better prepared so they can have really interesting conversations in their class that they couldn't have before. And then, so this is my strategy for educational improvement, that when we're designing this technology, we need to attend to what we know from the research about human learning in the design. So we use the learning theory to design the technology, but then we use the technology as the big data collector, because our theories of our understanding of human learning right now is still pretty new. It's not like physics, where we kind of have a lot of that worked out. Learning science as a science is pretty young. And to refine and get our better theories, we need a lot more data. We need a lot more data about a lot more students in a lot more contexts. And the power is we can use the technology to collect that data, use that data to refine our theories, use those theories to refine our technology, and we set up this virtuous cycle. And that's really at the heart of what OLI is about, is that process. And I'm going to close with a quote from Herb Simon, who was a Nobel laureate at Carnegie Mellon. And back maybe almost 15 years ago, 20 years ago, he said this. He said, "True improvement in post-secondary education will require converting teaching from a solo sport to a community-based research activity." And that's what I'm inviting all of you in this room to engage in with us, is this community-based research activity. Thanks. So I think we have a little bit of time for a couple questions, comments. Yeah?
Have you done any examination of how this is changing the what the instructor's doing in the classroom? Because this is a radical change. This is the instructor as, a response to, what they're learning about the students, rather than here's my course that I'm presenting over the course of this semester.
Yeah, so did everyone hear her question? No. I'll try and paraphrase it. Oh, you can go ahead and give her the microphone, then you can hear it.
So I'm wondering if you've examined how this has changed what the instructors do in the classroom, because this is a radical difference in how we deliver information to our students. We're being responsive to where the student is, rather than having sort of a pre-packaged set of information we're delivering.
Yeah, so actually I think of this as you point out, this is a learning curve for everybody. The students don't know how to do this necessarily either, so we're all learning together how to do this. And in terms of impact on faculty practice, that's a current research area. And I'll tell you, our courses are used by faculty in institutions all over the country of all different Carnegie classifications, if you will. And faculty, we don't prescribe how you use it, so faculty use it all very differently. Some faculty just use it as a replacement to the textbook because it's open, it's free, and so you can save your students the $150 or whatever that they would spend on their, say, statistics textbook. So you just assign the OLI course as you would textbook, and you can look at the learning dashboard or not. So some faculty just use it as a textbook replacement and still, are comfortable giving the same lecture essentially that they've always given, and that's fine. Some faculty, and what's interesting, because what usually often happens is after the first time of doing that, they'll get some feedback from their students about, I'll give you one example where one faculty member had laboriously essentially recreated all of his lectures around the OLI course. And because he didn't believe that the students could actually learn very much on their own. And so he spent a lot of time doing that. And after the first lecture, this couple students came up and said, you know, your lecture was a lot like what we worked on before we got here. Is that going to be the same every course? And the faculty, well, yes, but he also was doing discussion sections where he was having, this was our causal reasoning course, where he was having students analyze data and actually put the skills into practice. And he said, but in the lab, we're going to be doing these practice things, but yeah, the lecture will be pretty much that. And the student said, well, do I have to come? If I know if I already learned it? And he was, oh, well, I guess not. I mean, if you really think you know it, then you don't have to come to the lecture, but you should still come to the lab, and et cetera. By the end of the semester, what do you think had happened? Yeah, everybody's nightmare, right? The students weren't coming to his lecture. And so he could have had one of two responses to that. He could have said, okay, not doing this anymore, or he could do what he actually chose, which is, wow. You know, the students were getting a lot out of that time we were spending where we were actually doing these interesting case analyses. Everyone was coming to that. They just weren't coming to the lecture anymore. So what he ended up doing was the next semester, he just didn't lecture. And he instead used the lecture times, and in fact he had fewer of them, 2 times a week where he just did these case analyses, and students could just come and do the case analyses and put it into practice. And for him, it ended up being a much richer experience because he was getting to have much better conversations with the students. So that's, you know, one example. Some just use the textbook, some use it to actually change what they do in class. In one of the liberal arts colleges where this was used, they used the statistics course to accelerate the students' learning. They read the accelerated study. So the first 8 weeks, they had the students work through the statistics material and finish it in 8 weeks. But then they had 7 weeks left in the semester. And they didn't just say to the students, go away. Instead, what they did was they had the students pick a project that required them to put into practice the skills of data analysis, but pick a project in your major, because it was a service course, in your major that's interesting to you. And go out and find the data, do the analysis, ask a question, present a research result, and they had a little poster session at the end of the quarter where the students presented their analysis projects. And then they all peer reviewed each other's analysis, and the faculty peer reviewed it. So they were able to really enrich that experience for students because they could accelerate their learning in the first part, and then they also had the OLI environment still there. So when they were doing their analysis, it's like, oh, I don't know if I remember how to do a t-test, or if a t-test is really the right thing to do, they could go back and re-engage with the environment. So it's so we're seeing all over the map how faculty are using these environments in really different and creative ways. And we just started, you know, just started this semester instructor forums on our site because I have a lot of interaction with faculty. They call me and say, gee, what's a good pacing or whatever. And it's like, you know, what you really need to be doing is talking with each other. So we have little forums now, so statistics faculty or logic faculty or whoever can talk with each other about what are you trying, what are you doing, and how's that working. So that's kind of a long answer to your short question. And I am doing a study, just on the side, I'm doing a study looking at faculty perspectives on what's happening out there. You know, we hear a lot about, I hear a lot because I talk with all kinds of policymakers, foundations, administrators. You hear a lot about what they coin as faculty resistance, which just makes me crazy because it makes it sound like there's this unwarranted resistance or Ludditeness about not using these technologies. And so what I'm trying to do with this study is really bring in faculty voice about what do you really see happening in the larger sphere of higher education, and then how technology can, what the challenges are that are confronting higher education, how technology could be used to either mitigate or exacerbate the challenges we're facing. Because I don't believe in resistance. Yeah.
You know, you're at Carnegie Mellon is a major research university, and this, you know, learning initiative that you've been engaged in should be very applicable to a teaching university like Towson, where we're expected to teach 7 or more courses during a year. What knowledge or skill development do faculty need in order, and commitments do they need to make in order to be able to incorporate that in their teaching, whether at Towson, another research university, wherever?
That's a great question, and I don't have an easy answer to that. That is a big research question. I would say that is the #1 challenge for faculty in incorporating these kinds of new approaches and technologies into their practice is time. When you're being asked to teach 7 courses, the amount of time you have to really think through and prepare and respond to this flow of data you're getting is pretty limited. And that's a real challenge. And so what I'm trying to understand is how can we carve out that time so that faculty can really reflect and think about their practice and change it in ways that they want to change it instead of feeling like I'm being told to change it in a certain way. Yeah, I know that might not be a very satisfying answer, but that's the reason in our project we don't use a medical model of research into practice. The old figure out these things in the lab, come up with a finding, and then throw it over the wall so the practitioners out there implement what we found with fidelity or not, and that's what explains the response you get. I don't think that model actually works that well with medicine, but it definitely doesn't work in education. That's why we're looking at integrated research and practice, where the practitioners are also participating in the research. Because what's happening in the real world are not just variables to control. Those are what's really happening around learning.
Can I just ask, I'm back here.
Okay, yeah.
What is the application to the humanities? This is all very science-based, math-based, and I can see that it would be very useful for that, but you alluded briefly to history and English, and I'm just wondering, what is the parallel program for those of us in other disciplines?
Great, thank you for asking that. So we don't have, if you look at the courses we don't have yet a humanities course. We have French, language course. I don't know where John is here, but we don't have Italian. So in any case, but we are just starting right now, actually, a history course. And it's really fun. And I'll tell you that, and we're also starting an English composition course. The English composition course we're doing in collaboration with a bunch of universities. The lead university actually in that is the University of Mississippi. But we have institutions all over the country that are participating in that. And then with the history course, we are doing that one at Carnegie Mellon initially with the faculty at history faculty at Carnegie Mellon. And the point here is that I'm sure, and I know already, that those courses are going to look very different than the statistics course. And I expect they will. But the design approach is very similar. You bring together the domain experts with the learning researchers and the software engineers, and you start with the question of what is it that's really critical for our students to get out of spending 15 weeks with us? And then where do they really struggle? In that thing that we really want them to be able to get, where do they struggle? Where's their high variability? And then can we understand what's going on? What makes this hard? And how can we use the technology to support the students to work through that? Whether it's using the technology in this way, doing sort of the kind of student interacting with a computer, or using the technology to get the students to interact with other students, or students to interact with the expert. But we want to structure those in such a way that when the students are engaged, we can look at how they're engaging and what they're doing to make meaning out of what's going on with their learning. So anyway, any of you who are interested in working on the English composition, we're just starting that, and we're, and then with history, I don't know if we'll have that be a big project or not. But if anybody's interested in that, I invite you to help. Yeah.
Getting the hands of the commercial sector, or let's say employers. They say, you know what? By profiling, this student cannot learn in, for example, statistics, had trouble with the statistics, therefore their cognitive development or their reasoning is flawed. What I'm worried about is that profiling, and what I'm worried about, who is gonna have access to this and what are the uses? Have you thought about this and what are you doing about it?
Yeah, I love that you said that, because it's one of the things that concerns me too. I mean, I get concerned on a couple of levels. Your point is absolutely well taken, that the goal here is the data. And I'll get a little political here for a minute. I worry that we're gonna make the same mistake on the teaching side of our house as we made on the research side of the house. What I mean by that is, on the research side of the house, I don't know how many of you are researchers in the room, in order to sort of promote and tenure and so on, we do our research, we publish it in journals, we peer review each other's work, but we don't own those journals. And the journals then sell the subscriptions back to our libraries at really high prices. And our institutions get evaluated on how many of those journal subscriptions we have. And so we've taken this core part of our business and outsourced it to the commercial publishers. And on the research side of the house, there's a group of provosts that are trying to undo that and are trying to make that sort of re-own that process. And I worry about what's happening now on the teaching side, where we have a lot of these commercial entities engaging in creating these technologies which are going to become a core part of our teaching and learning practice. And we're not going to own them again. And that's what I'm trying to and it's going to happen. Having these technologies become a core part of our teaching and learning practice is going to happen. And my question is, who's going to lead it and who's going to own it? And I really think that not-for-profit higher education needs to come together and both articulate what's important for our students to learn, design how we're going to use these environments to support our teaching and learning, and also own the data. What we do with our data, because we do collect data now from tons of interactions, and we anonymize the data and make it available and put it in the Pittsburgh Science of Learning Center has a huge database and data analysis tools. So that data gets anonymized so that we can't identify who the students are, but it goes into the Pittsburgh Science of Learning Center database, and then any researcher in the world can access that data to make discoveries about all kinds of questions about human learning. It's probably I believe it is, the largest open educational database in the world. But yeah, I mean, I think it's really important to think through both, and we protect student data also. I mean, the data is always anonymized before it's released in any way. But some of the other entities do have that, what you're describing, as sometimes as part of their business model. That with the student's permission, will sell the top, 5% of students' scores, those students' names, to employers in high demand fields, and that's part of their business model. Provide that matching service. Oh, I'm out of time. Thanks.